this question. The weekly income of shift foremen in the glass industry follow the normal probability distribution with a mean of $1,000 and a standard deviation of $100. The question is to calculate what is the probability of selecting a shift foreman in the glass industry whose income is less than $790, more than $1,075, or between $790 and $1,150. Let's answer these three questions one by one. So, in the question, we know the distribution of random variable x. So what is the x? X is weekly income of shift foreman in the glass industry. Then it's given x follow the normal distribution. The population mean is $1,000. Standard deviation is $100. So this is what the question has given us. Now the question is to calculate the probability of x less than 790. So we can use the formula here to do the standardization to get the z-score of 790. So when x equal to 790, the corresponding z-score equals to 790 minus 1000 divided by 100, and we get the corresponding z-score is minus 2.1. So we can change this probability to this probability. Then to calculate the probability of a standard normal distribution, we can use the table given on the right hand side. What is this probability we want to calculate? We can actually draw a graph to help us to understand better. So now we want to calculate z smaller than minus 2.1. So it's actually the left tail of the standard normal distribution. Then how to find the area of the left tail? Because the standard normal distribution, the curve is symmetric, right? So that left tail equals to the right tail. And in order for us to use this table given here, we need to actually find the area between 0 and some z-score. So given in this table is the area between 0 and some z-score. So we can actually find the shaded black area. So what is the relationship between the shaded black area and our target right tail? The summation is actually equal to 0.5. So once we understand this part, we can write here this probability equals to 0.5 minus the black area. So what is the black area? Then we can apply the table here. So looking at the table, we need to find the z-score 2.1. So looking at the z here, z equals to 2.0, so it's here, and 2.0, 2.10, then we actually identify this value 0.4821 from the table. So we can write this 0.4821 in our workings here, 0.4821. So after doing the calculation, you will get the answer is 0.9 0.0179. So that answers our part A. Now for part B, we just need to follow the same steps. So let's do it quickly here. So for part B, we want to calculate x bigger than 1075. And for this probability, what is the corresponding z-score we want to find? So doing the calculation, you will get the z-score equals to 0.75. So you know that this probability is equivalent to z bigger than 0.75. Now, what is the area we want to find for part B? So same, we can draw a standard normal distribution, and now we want to find the z-score 0.75, and because it's z bigger than 0.75, so the area we want to find is actually the right tail. So how to find the area of the right tail? Same as before, we can actually use 0.5 minus the black area. And what is the black area? So we can use the table here. So let's see, z equal to 0.75. Then we actually end up here in this value. So that is the area for the black shady area. So we can then type our answer here directly. This equal to 0.5 minus 0.2734. So you get the answer is 0.2266. So that's our answer for part B. Now for part C, we want to find the probability of x between A and B. So between means smaller 790. You write the small value on the left hand side and big value on the right hand side, right? So we actually want to calculate this probability x between 790 and 1150. So same as before, we need to do the standardization and get the z-score for both values of x. And for value 790, we have already got the z-score from part A, that is minus 2.1. So we only need to do the standardization for another value 1150. So using the formula, we get the corresponding z-score is 1.5. So this probability equals to the z-score between minus 2.1 and 1.5. So what is the probability, the area we want to find in part C? We can draw a graph. So now we want to find minus 2.1 and 1.5, some area here. Okay? Then how to use the table on the right hand side to find this big shady area? Remember, from the table, what we get is always from 0 to a z-score. So from the table, we can easily find this part. So then we just need to find the area in this part, right? So same as before, for the negative value of z-score, we need to change it to the right hand side. So we just need to find the area between 0 and 2.1. Then that's actually our left hand side, right? So to write it here, maybe you want to say something like this probability actually equals to the z-score between 0 and 1.5 and 0 between 2.1, right? So you will be able to see by writing in this way, I can actually apply the table directly, right? So let's see 1.5, where is the corresponding probability? So Z equals to where is my Z equals to 1.50. So we get this probability, and then for another Z score, Z equals to 2.1. This is actually in part A, right? We already find this probability here. So we just need to sum up these two probability to answer question C. So it equals to 0.4332 plus 0.4821. And then you get the answer is 0.9153. So that's it. We have got the answer for all part A, B, and C. So to summarize here, to answer this kind of question using the table, the most important steps are, first, we need to do the standardization, get the corresponding z-score. And secondly is to draw the graph to help us understand what is the area that you are looking for in the question. Okay, so once again, two steps are very key to answer this type of question. The first step is to use this formula to get the z-score, and the second step is to draw the graph to help us understand how to get the area that we want to get. Okay, so that's how to answer this type of question using the table. We can actually get the answer very easily using Excel. So let me just write here. For part A, we can use the Excel function normal distribution here. As you can see here, normal distribution, it returns the normal distribution for the specified mean and standard deviation. So using this function, we need to specify what is the x value. In the question, the x value is 790. And what is the mean of our distribution? Is 1000. What is the standard deviation? Is 100. Is it the cumulative distribution function we want to use here? We always choose yes, true, when we want to find some probability of the normal distribution. So you can simply type 1 to denote true. And let's see what is the answer we get here. It's exactly 0.0179, right? Then for part B, again, we can use this Excel function, but we need to be careful. The Excel function actually gives us the probability for the x value starting from next infinity to the x value. So it's all the left tail. And for part B, if you look at the table, we actually want to find the right tail area. So what is the relationship between left tail and right tail? You need to understand the whole area of our probability and the curve is 1. So we can actually use 1 minus the left tail that is given by our Excel function, normal distribution. Then we can write what is the x value, what is the mean, what is the standard deviation, and that's it. 0.2266. For part C, we want to find the area between value A and B, right? So for this kind of question, we can actually use If I draw it here, let me just show you again. Using Excel function, how should we answer this type of question? So I draw it here. This is the area we want to calculate. So using Excel function, we can actually using this left tail minus this left tail. Then we get some area afterwards, right? So that's the logic. So we can type the Excel function x value 1 minus, the original x value, that is 1150. The mean is 1000, standard deviation is 100, minus the Excel normal function. Then another x value is the small left tail, 790. Then you can see very quickly, we get the answer that is 0.9153. So that's how we can use Excel function to quickly answer this type of probabilities. In this video, I have explained two methods. We have spent some time to explain how to use the table to manually answer the probabilities. And secondly, we have explained how to use the Excel function normal distribution to answer all the three questions here.